Next example, consider the system of linear equations. X1 plus 2x3 plus x4 is equal to this. Then this is the second equation, this is the third equation. So we have the three equations and four unknowns. So consider the augmented matrix AB, the matrix of coefficient, and the matrix of constant, its combination augmented matrix. So first write the system in matrix form. So the coefficient matrix is 1 0 2 1, and 1 1 5 2, and then 1 2 8 4, and the constant matrix is 5 7 12. Then we have to reduce this matrix to row echelon form by using elementary row transformation. So reduce this element to 1, already there is 1, so reduce these two element to 0. So the operations are R2 minus R1, or R2 plus minus 1 R1, and R3 minus R2, or R3 plus minus 1 R2. So we have 0 at this place, and so change in the second row and third row. So we have, this is the matrix after these two operations, transformations. Then we have to reduce this element to 1. It is already 1, so reduce this 2 to 0. The operation is what? R2 minus 2 R3 minus 2 R2, or R3 minus R3 plus in bracket minus 2 R2. So we have 0 at this place. While multiplying by minus 2, we have minus 6 plus 6, 0 at this place, and minus 2 plus 3 become 1, and then 0, 3, because minus 2 into plus 2 is minus 4, plus 7 becomes 3. And this is, now we have to reduce this matrix in order to solve the system by using Gauss elimination. We have, this is the echelon form. But if I have to solve the system by using Gauss-Jordan method, then reduce the matrix to reduce to echelon form. So if we observe the first column, leading one, this column contains 0 except 1. All the remaining element are 0 in the second column. But if we observe the third column, the fourth column, it contains leading one. It contains leading one, but we have to reduce these two elements to 0. So this is the operation R2 minus R3. By using this one, we have to reduce these two to 0. So R2 minus R3 and R1 minus R3. So we have this matrix, and this is the matrix in the reduced row echelon form. So this is the echelon form or row echelon form of the matrix AB, and this matrix is what? Is the reduced row echelon form of the given matrix. Now we will solve the system by Gauss elimination method, then use this matrix echelon form. So rewrite the equation. So we have x1 plus 0x2 plus 2x3 plus x4 is equal to 5 as the first equation. Then second equation, x1 into 0 becomes 0, x2 plus 3x3 plus x4 is equal to 2. And the next last equation, this into x1, this into x2, this into x3 becomes 0, x4 is equal to 3. So if we observe this system, after rewriting the equation, we observe that there are 3 equations and 4 unknowns. So we have to assign one unknown. So x4, the last equation gives x4 is equal to 3. Therefore, we have to assign either x1, x2, or x3. So we assign one of them. Suppose x3 is t. Suppose x3 is t. Then if we assign x3 as t, then this equation gives x2 as minus 1 minus 3t, and the first equation gives x3 as t. So x4 is already, we have 3. So if we assign, take x3 as t, and then by using these 3 equations by substitution, we have x1, x2, x3, and then we can write the solution in the form of set. So write in curly bracket, write in round bracket, that in round bracket 2 minus 2t as the value of x1, comma, write round bracket. First write curly bracket such that t belongs to R, and then in round bracket 2 minus 2t as x1, comma, x2 as minus 1 minus 3t, comma, x3 as t, and x4 as 3. And then if we write this in the form of addition of these two, so 2 minus 1, 0, 3 is the constant vector plus t into minus 2, that coefficient of t are minus 2, minus 3, 1 and 0, such that t belongs to R. So this is the set of solutions of the given system by using Gauss elimination method. And then Gauss-Jordan elimination method, or just a Gauss-Jordan method. So use this reduced row echelon form. So rewrite the equation. What do we have? X1, by using this, we have x1 plus 2x3 is equal to 2 as the first equation. X1 plus 2x3 is equal to 2 as the first equation. And second equation is x2 plus x3 is equal to minus 1 as the second equation. And the last equation is x4 is equal to 3. Again, we have three equations and there are four unknowns. So assign one unknown. Suppose x3 is t. Suppose x3 as a t or r or s. So this t is any real number. And then we have x1 as this, x2 as this, and x3 as this. x4 is 3. Already we have x3. And therefore the solution set is this: 2 minus 2t minus 1 minus 3t comma t comma 3, such that t belongs to R. And then you can write it is in the addition of these two vectors: 2 minus 1 0 3 as a constant vector, plus t, the coefficient of t are 2 minus 2 minus 3 1 and 0. So this is the solution set. So we have the same answer by using Gauss-Jordan method and Gauss elimination method. The format may be changed. It's depend on your calculation. So these are the some examples for homework. Solve these all examples by using Gauss elimination method as well as Gauss-Jordan elimination method. So answers are also given. The answer of 1.19. Consider the augmented matrix AB and reduce the matrix to echelon form or a reduced row echelon form. So this is the reduced row echelon form and this is the echelon form. So rewrite the equations after reducing the matrix to echelon form, then rewrite the equation. So this is the echelon form and this is the reduced row echelon form. So if you observe the echelon form, so the first column contains leading one, the second column contains leading one, and the fourth number column contains leading one. And if you observe this reduced row echelon form, then the columns first, second, and fourth contains all entries are equal to 0 except the leading one. So this is the reduced row echelon form. So by using Gauss elimination method, we have this is the system after rewriting the system equations. We have this system, and then again there are four variables and we have three equations. So assign one unknown, one variable, that is suppose assign x3 as t and then find x1 and x2. So this is the solution set, and by Gauss-Jordan elimination method, this is the solution set. So similar, by using same method, the answers of the remaining problem 1.20 by Gauss elimination method and Gauss-Jordan elimination method. If the rank of A, if we observe the rank of A and rank of AB in these problems, the rank of A and rank of AB both are same, are equal, and it is strictly less than number of variables. That's why we have infinitely many solutions. This is the answer of 2.21. So this is the echelon form and this is the reduced row echelon form. If you observe this matrix echelon form, then if we delete the last column, then it is this is the echelon form of the matrix A. And if you observe the number of non-zero rows in the echelon form of A, there are three non-zero rows, and therefore rank of A is 3 and the rank of AB is also 3, and therefore the system is consistent. The example 2.21, if you observe the example 2.21, 1.21, then it is a homogeneous system. All the constants are 0, so it is always consistent. but the system has either unique solution or infinitely many solutions in the case of homogeneous system. So the answer of 1.21 is this: the system has infinitely many solutions, has trivial as well as non-trivial solution. The answer of 1.22 by Gauss elimination method and Gauss-Jordan elimination method. If we observe this answer, then and the rank of A is 3, rank of AB is also 3, and the number of variables are 3. Therefore, this system has unique solution. So by using Gauss elimination method and Gauss-Jordan elimination method, we have the same answer, that is x1 is minus 23, x2 is 14, x3 is minus 6. By using Gauss-Jordan elimination method, we have the same answer. So the system has unique solution because the rank of A and rank of AB are same and are equal to number of variables. The rank of A is 3, rank of AB is 3, and the number of variables are also 3. Therefore, the system has unique solutions. Then this is the example: solve the system. So we are given 4 equations and 4 unknowns. So consider augmented matrix, reduce the matrix to echelon form. And if you observe, this is the echelon form of the matrix. This is the row echelon form or echelon form. This star, this is the echelon form, and this is the reduced row echelon form. So if we observe the echelon form of the matrix AB, then rank of AB is 4. This whole matrix is the echelon form of the matrix AB. So this is non-zero row, this is non-zero row, and the remaining 2 rows are 0 rows. So rank of AB is 3. And if you observe, if you delete last column, then remaining is the what? This is the echelon form of the matrix A. And if you observe the rank, this matrix row echelon form of the matrix A, then first row is non-zero row, second row is non-zero, then third and fourth row are 0 rows, and therefore rank of A is 3, rank of A is 2, and rank of AB is also 2, and therefore the given system is consistent because rank of A is equal to rank of AB. Because we know that rank of the matrix is what? The number of non-zero rows in echelon form, or the number of non-zero rows in reduced row echelon form is the rank of the matrix. So if you have to solve the system by Gauss elimination method, then use echelon form, this echelon form, and rewrite the equations. So we have the 2 equations: this x minus y plus 2z minus w is equal to minus 1, and the y minus 2z is equal to 0. So there are so we have 2 equations and 4 unknowns. So the difference is 4 minus 2, that is 2, and we have to assign 2 unknowns. So assign z as a t, z as any variable as a t, and assign w as a s. So assign z as t and w as s. S and t are any real numbers. S and t belongs to R. And then find y and x. The values of y is what? 2t, and x is s minus t from these 2 equations. So we have, this is the solution, that x is equal to s minus 1, y is 2t, z is t, and w is s, as s and t belongs to R. And we can write the system in the solution set in this form, that s minus 1, 2t, t comma s in round bracket. So is equal to, the constant vector is minus 1, 0, 0, 0 plus, and the coefficient of t are what? 0, 2, 1, and 0. And the coefficient of plus s, coefficient of s are 1, 0, 0, 1. So this is the solution set, where write it is in curly bracket, and then write such that is oblique line s and t belongs to R. So this is the solution set. Then observe that minus 1, 0, 0 is the particular solution of the given system, and this t in bracket 0, 2, 1, 0 plus s in bracket 1, 0, 0, 1 is the general solution of the corresponding homogeneous system of the given system. Corresponding homogeneous system of the given system. So what is the homogeneous system, corresponding homogeneous system of this system? So right, all these constants are equal to 0. This is the corresponding homogeneous system. Actually, the given is the non-homogeneous system. Its corresponding homogeneous system is what? Right, all these